We're graphing tangent, cotangent, cosecant, and secant today. You need to have out worksheet 14 and 15 because we're going to kind of flip back and forth between the two. I'm going to try to explain where these graphs come from and why they look the shape they look. We are going to do a few shifts and period changes, talk a little bit about an amplitude change. We're not going to really do phase shifts with these. Basically, there will probably be on the next test or quiz one tangent graph and one cosecant or secant, okay? This is not something I'm going to ask a million of. Before I go any further, today we're talking about reciprocal functions. For example, cosecant is the reciprocal of sine. Everybody okay with that? Those are equivalent, okay? This is not equivalent. Okay? This is an inverse function. This is a reciprocal function. The reason they're not equivalent has to do with the change in domain and range, okay? An inverse, we're going to flip the x and y. Not just flip it upside down as in 1 over, okay? All right. The book goes through an interesting discussion about how tangent comes from sine divided by cosine. It's kind of interesting, but it's not how I think of it. But let's just talk about this. Where would this sine over cosine be equal to 0? What would make a fraction be a 0? 1 over 1 is not 0. 0 over 0 is not 0. 0 divided by some kind of a number, yes? Okay. So where the sine is equal to 0, the tangent graph is also equal to 0. Okay? So here's a sine graph in light blue. Everywhere that equals 0 here, the tangent graph equals 0. What will make this graph undefined or have an asymptote? When the divisor, the bottom is 0, right? So the cosine of x equals 0 will give us vertical asymptotes. This light blue graph on this side is a cosine, and you will notice everywhere that it was 0, the tangent graph has an asymptote, okay? The other thing, you know, if you took, yeah, I'm not going to try their explanation anymore, okay? I'm going to go to the way I always think of it. We're going to flip over and look at worksheet 14A. On worksheet 14, I talk about slope. Slope is y over x, yes? So it's sine over cosine. What is the slope of this line right here? 0, okay? So that translates to this point right here. What is the slope of this line? Okay, so if I went 15 degrees, the rise over the run would be small or big? The rise divided by the run would be a little number, right? Less than 1. Okay? As you go further around, is that still have a slope of less than 1? Where does it finally hit 1? Some of you got it. At 45, isn't the rise and the run both the same on that 45? Okay? So it hits a value of 1 at pi over 4. Okay? Now, what is true about something up in here in terms of the rise and the run? The rise is much greater than the run, more than 1 times as much. If I go clear up to here, it can be really big, right? So these points continue to go up. Right, what happens when I get to this spot right here? What's the slope of that line? It's undefined. And that is what spot on my circle? Pi over 2. So over here at pi over 2, the tangent graph is undefined, and undefined means an asymptote. Right, when I move around here, what's different about the slope? It's going downhill, so it's what? Negative. It's very negative, though. Okay. Then as I get over to here somewhere, it would be what? -1. Okay. As I get over here, the slope is getting smaller, less than 1. Guys, rise over run. Rise right there divided by run. It's less than 1, right? It's a tiny little number. It's getting closer and closer to 0. When I get to here, I'm back to a horizontal line, so it's at 0. Now, does the slope change when I go down here? The slope of this line at pi over 4 is exactly the same as it is down here at 5 pi over 4, right? Because it's exactly the same line. The slope doesn't change. So how long until we've covered all the values? Not 2 pi, but 1 pi. Okay? That's one period right there. Okay, because the slope starts to repeat as we go around. All right, so here's what the tangent graph does. It goes through 0, 0. It goes through pi over 4, 1 if you wanted another ordered pair, and then it gets infinitely large. On this side, it has an undefined place at negative pi over 2, or a vertical asymptote, and it would get negative. It would also go through negative pi over 4, -1 if you wanted another ordered pair. And it will repeat over here. Where is the next undefined place? That one's not drawn very well. It doesn't look like a straight line. Okay, the next undefined place would be at 3 pi over 2. Oh my goodness, that graph is horrid. Horrid, horrid, horrid. Let me try one more time. Oh, that's not much better. I'm trying. Okay. Anyway, that's my attempt. What's the period? What? Yeah, it's 5th hour. What's the period of a tangent graph? Do you see, guys? Students struggle with this because, watch. I'm just going to highlight this and then I'll unhighlight it. That's the up branch, and this is the branch. Now it has finished one cycle because it's done both the up and the down piece by pi. That's hard for us to see. Most of us would prefer, really, my undo button has to be under here somewhere. Okay, really most of us look from here to here, and that seems like one cycle. Do you see that? But that distance from negative pi over 2 to positive pi over 2, that's still 1 pi. Okay, so the period is pi for a tangent graph. What about maxes and mins? Are there any? Okay, because there are no maximums and minimums, there is no amplitude. Everybody okay with that? Does not have an amplitude. You can still put a number out in front, like 2 tangent of x, and it will vertically stretch. At pi over 4 instead of 1, it would be at pi over 4, 2. But it isn't really called an amplitude change. It's just a vertical stretch, which is what it's always could be called. But does anybody remember what it means to be an even or odd function? This is y-axis symmetry, and odd is origin symmetry. What does origin symmetry mean you can do to it? Rotate it 180 degrees, and I'm pretty sure I can't manage to select this whole thing. Okay, we'll try that one. If I flip this upside down, it's the same shape, right? Not really, but we'll pretend. So it has origin symmetry. I can draw much better if I go stand up there at the board, but then 2 things happen. 1, I'm in the way of somebody, and 2, the sound recording isn't as good. And I got 3 people, or at least 2 people still on homebound, so I'm trying to record these. All right. The next thing I want you to do is we're going to talk a little bit more about where these lines are. We already talked about this real quick. There is no such thing as amplitude, and the period is just pi. Okay? But can you look at worksheet 15A real quick? If I were asking you to draw this on a homework assignment, you would need to label at least 2 asymptotes and at least 2 ordered pairs. Okay? So you could say it has an asymptote at negative pi over 2 and positive pi over 2. You could say it has a 0 at 0, 0 and a 0 at pi 0, and that would be good. Its domain is all real numbers except, is this correct? The odd multiples of pi over 2 don't work? 1 pi over 2, 3 pi over 2, 5 pi over 2, that's where the asymptotes are, right? Negative 1, negative 3, negative 5. Okay, there's a couple typos on this worksheet. We'll see if we can catch them. All right, in the middle of that worksheet 15, side A, it says this. I just want you to make sure you know that if the graph is tangent or cotangent, is the period 2 pi over b anymore? What did this slide say a second ago right here? It's just pi over b. Okay? So if you had a tangent or a cotangent graph, it's pi over b. Otherwise, that little section is not anything new, right? On tonight's homework, there are a couple questions that you have to use the calculator for, and I'll talk about that at the very end of class, but it says make sure you're in radian mode and you use Zoom Trig. All right, we're going to try this at the bottom of 15A. What shape is a tangent graph? Kind of like a cubic, right? It's like this. Okay? What is the negative? Because I keep messing this up all day. I keep forgetting it says negative. Yeah. So it's actually going to go this way. And then it's going to repeat. And I'm just going to go ahead and draw it. And then we'll figure out where these asymptotes should be at. Okay, what is the new period for this graph? Pi over 4, right? So what you're saying is that if this is a total length of pi over 4, each of these asymptotes are actually pi over 8, negative pi over 8. Where'd the next one be? 3 pi over 8 is right. Because in between there, at 0 and 2 pi over 8, which is a pi over 4, it should be crossing the x-axis, yes? Okay, that's good enough graph for me. I labeled 2 asymptotes at least, and I labeled 2 ordered pairs. We good? If I were actually being correct, the asymptotes have equations. They're not points, right? They're x equals line, vertical lines. All right. What's going on this one? We had one like this on the homework, and it didn't go well for some of you. What is this -5 doing out here? Yeah, you can move it back here if you want, and some of you actually did that on the quiz. It is a vertical shift down 5. Okay, so the midline, so to speak, is going to be down 5. Now, normal tangent is this shape. Right here, it goes through the origin. So when I shift it down 5, it's going to be down here somewhere. But what else is going on? Is that really the right words for that? Yeah. Has no amplitude, you're right. It is a vertical stretch. A vertical stretch on a tangent, guys. A vertical stretch on a tangent or cotangent graph is hard to see. Gentlemen, please stop talking. Okay? If I were to graph tangent of x and 2 tangent of x in the same little zoom trig, you would barely see a difference, okay? It just stretches it up a little bit faster. But the negative here does what? Yeah, my vertical stretch should really be pointing to the 2, not the negative, because the negative does what? Oh, she is going to kiss your feet because this is in as a 0. Samantha, your quiz found its way home. You know what's really funny? Remember last week when you took a homework check? It was Samantha's then too. So Miss Bay's out for you, Samantha. All right. So it's reflected over, so the shape is going the other way, and it's going quickly. All right, so I'm going to call this -5, and I'm going to draw this quite vertical. What's the period, though? The period is not changed, so the period is still pi. So that means where it crossed here was 0, -5, and the next time it crosses that -5 midline would be pi -5 and 2 pi -5. Where are the asymptotes then? Yep, pi over 2. What's this one? 3 pi over 2. There'd be one over here at -pi over 2. Yeah, pretend that says -pi over 2, okay? Pretty good? All right, this is back on worksheet 14. We're going to talk about where the cosecant graph comes from. If you want colored pencils, there's some back by Max. Just while you're back there, wake him up and tell him to take notes, okay? You awake back there? All right. I have graphed on here for you a sine graph that goes through 0, 0. This would be pi 0. This would be 2 pi, where it finishes one cycle of the sine graph, yes? 3 pi, -pi. What are those places going to become if we're talking about a reciprocal? If those were 0, what happens when we do the reciprocal? What's the reciprocal of 0? When the 0 moves to the denominator, it's undefined. So we have asymptotes. Everywhere that this graph had a 0, there will be an asymptote, and those are so badly drawn. trying to cheat and use the line tool, but somehow they're still coming out in the wrong spot. All right, let me try scooch a couple over. Whoops, that wasn't what I meant to do. All right, so those asymptotes are at 0, 1 pi, 2 pi, 3 pi, right? Every multiple of pi. All right, hang with me here. What's this ordered pair right here? At pi over 2, this graph is at 1. What is the reciprocal of 1? 1 divided by 1 is still 1. So the reciprocal function still goes through pi over 2, 1. All right, say over here there was at 3 pi over 4, it was at 1/2. What's the reciprocal of 1/2? 2. Down here, really close to pi, it got all the way down to 1/10. What's the reciprocal of 1/10? 10. Same thing on this side, right? Over here, reciprocal. The actual cosecant graph does not include any of the dotted stuff. It's that piece right there. That's the cosecant. Now, over here, at -1, at 3 pi over 2, it was down at -1. What's the reciprocal of that? Reciprocal of -1, still -1. So that point is still part of the cosecant graph. But as it gets close to 0, like -1/10, it would be clear down at -10. Oh, don't know what that is right there. Let's try going this way first. It's bad on both sides. I don't know. Doesn't hit the asymptote either. I'm trying. I'm not doing a very good job. All right. The rule, again, I want at least 2 asymptotes and at least 2 ordered pairs. Did I do that? I got pi over 2, 1, 3 pi over 2, -1. These asymptotes are at x equals pi, x equals 2 pi, x equals 0, x equals -pi. We good? Okay, what's the period? The period has to include still the up and the down branch, right? So that right there, from 0 until 2 pi, is where we get the whole period. Does it have an amplitude? No. It can have vertical stretch, but it will not have an amplitude. On 15b, look real quick. Again, everything that's dotted is a guideline to draw the function. The actual cosecant are just the solid pieces. Everybody okay? All right, is this right? The domain is all real numbers except odd multiples of pi. There's one at 0. There's one at pi. There's one at 2 pi. Are those only the odd multiples of pi? It should say all multiples of pi. The cosecant is undefined at all multiples of pi. It is an odd function. It's a reciprocal of sine, which is an odd function. All right, quickly back on 14b. Hope you don't have whiplash yet from flipping back and forth. I'm going to try to stretch this graph a little bit, see if it'll make it easier for me to try to... Okay, where am I going to put asymptotes? Yes, wherever the original function had a 0. Can you tell me where those were? The original function in dotted line there is what? What's the name of the one that's dotted? Yes, if I'm doing secant, the dotted one, the reciprocal function is the cosine, sorry. So here's 1 period of the cosine. Everybody see that? So this is 2 pi. So where are those asymptotes at? Yep, 1 pi is where there's a minimum. Where it crossed here was at pi over 2. So x equals pi over 2. X equals, what's this asymptote at? Halfway between pi and 2 pi would be 3 pi over 2. X equals 5 pi over 2. So this time it actually is the odd multiples of pi over 2. Do you see that? For the asymptotes, -1, 1, 3, 5 pi over 2s. All right. Where are a couple ordered pairs? Nope. Yeah, at 0 there'd be a value of 1. At pi there'd be a value of -1. Because the reciprocal at 1 or -1 is just itself. Okay, so it's exactly the same shape as cosecant, but if you graph the sine, the cosine graph first, and then you find all the zeros and put in the asymptotes, then you just flip all the little u's the other direction. Everybody okay? Okay, so let's go back to 15. I think it's B. Is it on B? Is this right? For secant, is it odd multiples of pi over 2? Pi over 2, 3 pi over 2, -pi over 2. We good? So this one is correct. Does everyone see that is an even function this time? Okay? I can fold that in half this way and it'll match up, right? Across the y-axis. All right, cotangent, last one. Finally. Where are there going to be asymptotes this time? Wherever the tangent graph was 0, the reciprocal will be undefined. So the reciprocal function of cotangent will have asymptotes wherever there were zeros. Can you tell me where those were? Where's this one? Yep. So this one would be 2 pi. The period is pi. All right, one more time. What happens to where this was undefined? Where the tangent was undefined, meaning the 0 was on the bottom. When I flip it over, the 0 will be on the top, so I will get what? A 0. So where the tangent graph had asymptotes, the cotangent graph has zeros. Where would those be at? Remember, this was 0, pi, 2 pi. So these are at pi over 2, 3 pi over 2. And then everywhere, and -pi over 2 over here. Everywhere that this graph was small, the reciprocal will be large. Everywhere it was large, the reciprocal will be small. Everywhere it's positive, the reciprocal will still be positive. So it's going to go like this. Okay, that's pretty bad, but you get the right idea. I tried. All right, in here somewhere would be, if you don't have to do an ordered pair other than the zeros. I'm fine with that. But you would have pi over 4, 1 still, because the tangent and cotangent are both 1 at pi over 4. Because sine and cosine are equal. All right, so on our notes, is this correct? The asymptotes are at the odd multiples of pi. The asymptotes are at 0, pi, 2 pi. So it should be all multiples of pi, right? And cotangent is again an odd function. If I took that graph and flipped it upside down, it would still be the same shape. All right, bottom of 14a, we're going to do some of these. I would like to go kind of quickly. All right, we're going to graph at least 4. We're going to graph at least 2 asymptotes and at least 2 ordered pairs. To graph this, you are thinking about graphing 2 cosine of 3x. I'm going to graph it as dotted and red. What can you tell me about that graph, 2 cosine 3x? How high and how low does it go?
2.
And it finishes at, okay. Yeah, this should be -2. Sorry, I don't know why that said -1. I don't know why I always draw more cycles of this than I do other kinds of graphs, but it just feels like I need to. Where are there going to be, that's enough for right now, right? Where are there going to be asymptotes when we flip it over? Yeah, wherever that had zeros at. Those are so badly drawn. All right, that's as close as I'm going to get. All right, now I'm going to flip all my little U's the other direction. And I need some ordered pairs, and I need some equations for asymptotes. Anybody got me for either one? An asymptote or an ordered pair? All right. Yeah, these are kind of tricky. If this is 0, 0, this is 0, 2. That wasn't too bad. This one over here is 2 pi over 3, 2. So what's halfway in the middle? Between 0 and 2 pi over 3 would be 1 pi over 3. And that's down where? -2. Yeah, it had a stretch, and I didn't label mine right the first time. Okay. The asymptote, though, is happening between 0 and pi over 2, which would make it, that's not right, that's a 3. Thank you. That's a pi over 3, just like you said it was. All right, between 0 and pi over 3 would be, half of pi over 3 is pi over 6. So this is 1 pi over 6. 2 pi over 6 is the same as pi over 3, right? So the next one here is 3 pi over 6, or pi over 2 is that asymptote. 4 pi over 6, 5 pi over 6, we got it. Oh, that is a hot mess. Look at all that scribbling. All right, flip the worksheet over really quickly. This is like a 10-second review. What's the period of this function? Sine 3t. 2 pi over 3. Too bad I can't write that. What's the, I gotta erase that, it's gonna bother me. This one would be 2 pi over 5. What about this one? Oh, because it's tangent, it's just pi over 3. And this one is tangent also, so it's, okay, That was my 10-second. Make sure you realize if it's sine or cosecant or secant, it's 2 pi over. If it's tangent or cotangent, it's just 1 pi over b. All right, here we go. What's the period of this thing going to be?
No.
1/4. What is the 3 going to do? Yeah, it's a vertical stretch, so it just makes it go up very quickly. All right, it has to finish a whole cycle by 1/4. Remember, tangent does this, though, and goes through the origin, right? Where's the asymptote going to be then? No pi's on this graph. It's doing this, right? No, that's when it finishes its cycle as 1/4. Where's the asymptote halfway there? 1/8. So there are asymptotes at x equals negative 1/8 and x equals positive 1/8. Oh my. That's a straight line. Yeah, it's one of those Wednesday Mondays. That makes it worse, doesn't it? Okay. I tried to draw them a little straighter than normal because of the vertical stretch. I'm not going to worry about it. You need some ordered pairs. There's 0, 0. There's 1/4, 0. There's my 2 ordered pairs and my 2 asymptotes. Good enough? Sorry, Faisal. It's a disaster. All right, guys. What do I sketch first? 3 sine 2x. I'm just going to draw a sine graph. Oh.
It's a Wednesday. Bye. Trey's leaving. Trey's done.
Oh my gosh, that's horrible. Okay. Where are the maxes and mins? 3 and negative 3. Where does it finish one cycle? 2 pi divided by 2 makes this pi, which makes this pi over 2. Where are the asymptotes when I go to do the reflection then? Everywhere that this had zeros. So at pi over 2, pi, negative pi over 2, 0, there's 1. Oh my goodness, I don't know what I did there. Okay. I graphed that blue thing solid. It really shouldn't be solid. It should be dotted because what do we still have to do to graph the actual cosecant graph? Yes. The actual cosecant graph is this shape, but it doesn't touch the asymptotes, unlike my badly drawn one. Oh, that one's so far from the asymptotes, it's not funny. All right. I need some ordered pairs. Be careful. Yep, halfway between 0 and pi over 2 would be pi over 4. And at pi over 4, it's up at what? 3. What about 1 down here? 1/4, 1/2, 3/4, right? And it's down at negative 3. Are we good? Couple ordered pairs, couple asymptotes? Yeah, I'm definitely not good. Maybe just below fair. All right, what happens here? What's the period? Pi divided by 1/2 becomes 2 pi. Where are the asymptotes then if it's a tangent graph? Yes, because you go a little bit on either side to cover that 2 pi. Why did I think I could do those by hand? Okay, what's the only other thing that changes about this one? Yeah, but it flips upside down, right? It actually flips upside down. Yeah, as long as you don't have a vertical. Oh, I don't even know. It's getting closer to the asymptote, not further away there. And that crooked asymptote didn't help anything. All right, so couple order pairs, anybody? 0, 0, there's a good one. 2 pi 0. What else? Asymptotes are at x equals negative pi, x equals pi. The next one would be at x equals 3 pi. All the odd multiples of pi. Ever got something down? They care. Cotangent. What do you got to remember with cotangent? Besides it's an upside down sign. Yes, the asymptotes shift. They start at 0. There's an asymptote at 0. Then where's the next one because of our period here? Okay, normally the next asymptote would be at pi, but this one is at pi over 2. So the asymptotes are at x equals 0, x equals pi over 2, x equals 2 pi over 2, which is, there'd be one over here at negative pi over 2 as well. All right, anything else I got to remember? Is it going like this? That's the tangent shape, right? Cotangent goes the other direction. So it's doing this. We got to figure out where those zeros are. Oh my goodness. I'm just giving up. Okay, where are these zeros on these horribly drawn cotangent graphs? Half-weight of negative pi over 2 would be negative pi over 4, positive pi over 4, and halfway between a half and 1 would be 3 pi over 4. All right, what's going on here? Guys, we haven't had very many of these. This one is a cosecant, but we haven't had very many vertical shifts, right? Okay. I tried to scratch the graph paper a little bit for you. It's up here at 3. So when you draw the sine graph, by the way, these are pi over 2, pi, 2 pi. What's the amplitude? Okay, the sine graph would do this. Well, that's not too bad. We'll see how bad I can do on this side. Yeah, pretty bad. Okay. Where are the asymptotes then? Wherever there aren't zeros. Wherever it crosses the midline here. Oh, yeah. So if you're not laughing by now, I don't know what'll make you laugh. Because these are ridiculously bad. Okay. Now this is going to flip this way. Ooh, that one wasn't too bad. Order pair right there, guys. negative 3 pi over 2 comma 4, because it was up 3 and then it went up and down 1. So this would be negative pi over 2, 2. There's a 0, 3 here. No, there's not. I totally lied. 0, 3 is not part of that graph. That's an asymptote. Just kidding. One more ordered pair. Give me a positive one. Pi over 2, 4. Over here we'd have 3 pi over 2 negative, or 2. All right. Oh, faster I draw, the better it looks. Is that the last one? Seriously? Okay. I don't care if you don't do this one, but there's a negative 1. What would pi divided by 1/3 be? 2 pi divided by 1/3 would be 6 pi. It is a cosine, so it would start here and finish by 6 pi. It would have asymptotes there. If that's 6 pi, this would be 3 pi. This would be 3 pi over 2. 3 plus 3 is 6, plus 3 is 9 pi over 2. All right. Please listen closely. Look up here. Stop packing up. All right. This is going to be the worst explanation ever of this, but this shows a cosine graph and a vertical horizontal line at 1/2. It also shows that it crosses at pi over 3, and then it crosses again at 5 pi over 3. And the next time it would cross would be 2 pi after that, and then 2 pi after this. So you could write this. Does everybody agree that the period is 2 pi? So it's going to repeat every 2 pi. Because it is a cosine graph, it's actually doing it evenly on either side, so a shorter way to be right this. Okay, I talked about the calculator questions. It's going to tell you these 3 questions to do on your calculator. You're going to type this in Y1 and this side in Y2 and see where they intersect. Just find the points of intersection. How do you type 2 secant of x in your calculator? 2 times 1 divided by cosine. Or you could even do 2 over cosine would work for that one. Okay? And it says like between 0 and 2 pi or something. All right, guys. Thanks. Have a good afternoon.